Alrighty, let's get this started. What are we doing? Well, we're gonna do the same thing we did yesterday, but we're gonna build upon that. The idea is derivatives, right? What does this actually mean? It just means it's the slope, okay? What is slope? Slope is rise over run. Derivative gives you the m value function. It doesn't give you the m value outright. It's gonna give you the m value function, and then you can plug in an x value into the equation to get what the m is if you want a number. For example, x squared, let's say this is y. Y prime would be 2x, right? You see this is the function, the derivative function. And then you can plug what's the slope when the x value is 0 or something. Well, the slope y prime is just going to be 2 times 0. It says 0. So that's the whole idea behind it. It's going to give you the m value function. It's because anything that's not linear, the slope is going to change. Like, for example, the slope is here, the slope is here, slope is here. That's why you need the function itself as well as the x value, and that's going to give you all these m values. Slope is also another word for rate of change. All right, let's get this started. And you can, like, we found y prime from y. This means it's the first derivative. What you can do is you can go infinite number of levels below if the function permits. You can find y double prime. This means you first find y prime, and then you find its derivative again. So if you start from the beginning up top, you're going to do this once, and then you're going to do this a second time. Usually this is as far as you want to go, double derivative, because after this, usually most functions become a zero. Not everything, but polynomials will definitely become a zero, I guess, but not everything. If it's a rational function like this you can go infinitely. Let's look at a quick example of a second order derivative. Which form is this in? Is this a product question or is this a quotient rule?
Quotient?
Yeah. Anything in the numerator is f, anything in the denominator is g. And quotient rule says it's going to be f prime g minus f g prime over g squared. Right? Now let's find f prime of x. What's f prime? Just the numerator. Yeah, it's just a 1. And then you multiply this with the denominator as it is. So 1 times 1 plus x is just 1 plus x. Minus x times, what's the derivative of the denominator?
It's also 1.
Yeah, it's also 1. So x and minus x cancels out. And then in the denominator, you'll get what? If you look at the formula, what do you get in the denominator? It is g squared, right? G is 1 plus x. So it's just going to be 1 plus x squared. The denominator as it is squared. And there you go. That is the first derivative, okay? But then you can go a level deeper. Second derivative. So f double prime of x, same idea. Now this is our f, and this is our g, right? What's the derivative of 1?
It's just 1.
No, it's 0. 1x would be 1. The derivative of any number is a 0. So you have 0, that's f prime, times g as it is, yeah, like this. 0 times this is still a 0, so you can just ignore that. Minus, right, we had a 0 here, minus f as it is, so 1 as it is, times the derivative of the denominator, g prime. If g is 1 plus x squared, how do we go about finding g prime?
You bring the 2 in the front?
Yeah, you bring the 2 in the front, and then you'll get a 1 up there, right? And then you multiply this with the derivative of the inner bracket, which is still a 1, yeah, like that? All over this squared. Okay, this is going to be tricky. What is 1 plus x squared squared? So this is g right now, right? This is g. We want g squared. Any ideas? Think of it this way, x squared, right? This is, just think of x squared. What happens if you square this? What do you get?
X to the power of 4.
Same idea here. You have 1 plus x squared, like whole squared like this. If you square this entire thing again, right? This entire thing again, you get 1 plus x to the power of 4, like that. Okay. Anything squared, double squared, you just multiply the exponents. And we're basically done. We can kind of clean this up. -1 times 2 times 1 is just -2. Then we have 1 plus x here, and then we have 1 plus x to the power of 4. Can I cancel out this 1 plus x with one of the 1 plus x's in the bottom?
Yes.
Yeah, you can. So this is going to be your final answer, -2 over 1 plus x cubed. And that is your second derivative. And they want the actual number. They've given you a value of x, just plug x in there. You get -2 over 2 cubed, which is 8. So you get -1 over 4 as the final answer. Okay. Second derivative, first find the first one. This one was a quotient rule. Didn't really need the chain rule. I guess we needed the chain rule for this one, but it didn't really matter because the derivative of the inner part was just a 1. Here's another idea. Where is this used? You know distance, right? Distance is like kilometers. Basically, the units would be kilometers, meters, centimeters, anything. Distance is a length, okay? Is a measure of length. And then there's the holy pyramid of distance, time, and speed or velocity. Let's, distance, time, and velocity. Velocity, right? Velocity is rate of change. I'm just gonna call it ROF, rate of change, or ROC of distance. You take the distance function, for example, let's say y is x squared, y prime is 2x. If this is your distance, this is gonna be your velocity function, okay? The related distance, velocity, and well, time plays a part because, yeah. And then the third, if you find the second derivative, you get something. Well, what's the derivative of 2x? Nope. Derivative of 2x is just a 2. Anything with one letter and one power, like x to the power of 1, you just drop that x. This is, so again, velocity is a rate of change of distance. This thing that we found, the second derivative, this is something called acceleration. And this is the rate of change of velocity. So you have distance. If you take a derivative, gives you velocity. If you take another derivative of this will give you acceleration. So they're kind of related, okay? One is the rate of change of the previous one. Let's see this question using that idea. Looks tricky, but if you look at the function s of t, it's just a polynomial function. It is super easy to find the derivative of. So determine so they've given you the position. Position is just another way of saying the distance. Part A is asking you to find the velocity and acceleration of the object when the time is 2 seconds. If they give you the distance function or the position function, to find the velocity, you simply take the first derivative. What's going to be the first derivative of s? So we're basically trying to find s prime of t. What's the derivative of 6t squared?
12t.
Yeah, 12t. What about t cubed?
Minus 3t squared.
Yeah, minus 3. Let's go a lever deeper. S double prime of t, what would that be? Take the derivative of the first one, s prime of t.
It's 12.
It's 12, yeah, and then the other one is 6t, right? Like that. And they want this when the time is 2 seconds. All you gotta do for part A, plug 2 into the first one. So if you find s prime of 2, this will give you the velocity when the time is 2 seconds at 2 seconds. So you simply plug that in. 12 times 2 minus 3 times 4. 24 minus 12, it's a 12. All right, what's gonna be the unit of this? Again, remember, this is a slope, right? Our initial function, s of t, on the y-axis, we have time is always going to be on the x-axis. Time is independent. So you have seconds on the x-axis and s is meters. So you have meters on the y-axis. What will be the unit of the speed or the velocity function? It's going to be rise over run, right? Y over x, rise over run. So it's going to be meters over seconds. So what does this mean? This means at 2 seconds, the object is traveling at 12 meters per second. Okay? And we can do the same thing for the second derivative. 12 minus 6 times 2. This gives you a 0. Right? This gives you a 0. And again, what's going to be the unit of this? The velocity function, you have meters per second here. And you have a second here. So do meters per second. Again, it's going to be y divided by x. So meters per second divided by second. Turn this into times 1 over second. It's going to be meters per second squared. And that is the unit of acceleration. Okay?
Okay.
So what does this mean? This means that time equals 2, the object is moving at 12 meters per second, and it's not accelerating. The acceleration is 0. What does acceleration actually mean? It means how fast your speed is changing. So at that point, the speed is constant. That's what that means. It's traveling steadily at 12 meters per second. B, at what time is the object at rest? What determines something is at rest? Something's going to be 0, basically. Rest means it's not moving, by the way. Rest means it's not moving. You have 3 options. Is it distance? When distance is 0, you're not moving. Is it speed? It's one of these two. It's not acceleration. It is going to be the speed, okay? When the speed is 0, you're not moving. Or when the velocity is 0, you're not moving. So to do part B, yeah? All you have to do is set the speed function that we had up here equal to 0. So you have 12t minus 3t squared equals to 0, like this. Is there something that we can pull out? What's the GC of? Yeah, it's 3t. What else? What are we left with? Again, you had 2 terms, so there should be 2 terms in this bracket.
(4t minus 3t).
4t is right, but it's not going to be 3t, because if there's a 3t here, you would have gotten 9t squared. It's just going to be 4t minus, it's going to be actually 4 minus t. Yeah, that works. Okay.
Okay.
So you have 3t equals 0 and 4 minus t equals 0. This means when the time is 0, the object is not moving. Move the t to the other side. When time is 4 seconds, the object is not moving. Cool? Is this hard? It's something new, I guess. Distance, velocity, acceleration. Take this, we'll give you this. It's just we're gonna go, yeah, well, this is as far as we go, actually, second derivative. But you could technically go 3, 4, 5, 6. C, in which direction is the object moving when time is 5 seconds? So basically, is it moving up or down? That's what it says, I think. To do this, right, it's moving. Something moving means it's gonna be the velocity, the speed. We're gonna have to end up graphing this guy. It's actually not that hard because we already have the 2x intercepts and we also have the y-intercept, right? What's the y-intercept? It's a quadratic. It doesn't have a constant. That means the y-intercept is a 0, like that. So we're gonna go through the origin. We know we're gonna come back down at 4 seconds, yeah? Any ideas on how to find the vertex? The vertex will always be directly in the middle of the 2x intercept. What's in the middle between 0 and 4, the midpoint?
2.
2, right? You plug 2 in here, in this equation or in this equation, that'll give you the vertex. So 12 times 2 minus 3 times 2 squared, 24 minus 12, it's gonna be a 12, okay? Actually, we had this before from part A, I guess. So at 2, it's 12, yeah, like this. So our guy is gonna do this. It's gonna go all the way to 12, and it's gonna come right back down. Now look at 5. When time is 5, are we going up or down?
Down.
Down, exactly. So that'll be the answer to this one. The object is moving down. Okay.
Okay.
When is it moving in a positive direction? Again, you can look at the graph. It's gonna be in a positive direction when x is or t is less than 2. Like here, to the left of 2, it's moving in a positive direction. Yeah.
Mm-hmm.
When does the object return to its initial position? What's the initial position? Now for this one, where it's asking you for the position. Let's look at the position function. You have 6t squared minus t cubed equals 0. When t is 0, your position is 0, right?
Mm-hmm.
How do we factor this? What can we pull out, basically? We can pull something out. What's the GCF?
T squared.
Yeah. What are you left with?
6 minus t.
Yep, that's good. So this means t squared is 0. If t squared is 0, what's t? Square root both sides. What's the square root of 0?
Just 0.
Yeah. What about the other one? 6 minus t is 0. What's t?
Is it -6?
No. So just move the t to the right. Add t on both sides. It's just 6. Add t on both sides. Or you could subtract 6 on both sides as well. Get negative t is -6, so t would be 6. And you're done. Okay?
Okay.
So at 6 seconds, he's gonna come back. Yeah, this one was a little bit complicated, but you don't have to worry too much about this just yet. This one's way easier than that. It's the same kind of idea. So again, what kind of a function do we have here? If you look at this, right? Power 2, what does power 2 mean? It's a quadratic, right?
Mm-hmm.
So we have some quadratic function. It's a distance function. Is it opening up or down?
Down.
Yes, it's opening up down like this. Maximum height. On the y-axis, we have meters or whatever. Yeah, it's meters. On the x-axis, we have time in seconds, okay? So we're trying to find this point. You see this point? Now notice if I draw a tangent line here, right? What's gonna be the slope of that line? It's horizontal. What's the slope of a horizontal line? No? Here, we can do rise over run. Let's say we go from 1 to 3, okay? That's our run. But the rise, let's say we started from 4, right? So rise, what's the rise from here to here?
2.
No, that's the run. Rise, there's no rise. The rise is 0. Over here, you're a 4. Over here, you're also at a 4. But the run is 2. 0 over 2 is a 0. In fact, anything horizontal, a straight horizontal line means its slope is 0. The slope of a horizontal line is always 0. Okay?
Okay.
How do we find the slope? You find the derivative, right? That's what we've been doing this whole time. To find the slope, you simply find the derivative. What's gonna be s prime of t?
Negative 10t
Yeah,
plus 30.
yeah, that's it. Negative 10t plus 30. But then we're trying to find what's the time, okay? So that we know this is gonna be 0 because the slope at that point is 0, but we were more interested in finding what's the time. So negative 10t plus 30. You have a linear equation. How do you solve this for t?
Subtract 30, divide by 10.
Divide by negative 10. Like that. And then you will get 3. So when the time is 3, you'll have the maximum height. And to find its value, you simply plug t as 3. So negative 5 times t squared plus 30 times t, which is 3, plus 1. What's this? Negative 5 times 9. Negative 45 plus 90 plus 1. This is 45, so 46. The maximum height is at 46. Okay?
Mm-hmm.
Does that make sense?
Yes.
So what did we do here? They're asking us to find the maximum height. We know whenever something is maximum or whatever, especially for a quadratic, at a maximum height, there's going to be a turning point. And at any turning point, the slope is always horizontal. Let's say they asked us for a minimum height. We'll do the same thing. We'd find the slope function. You could have done this another way, which is finding the x-intercepts and then finding the midpoint of them to find the maximum. But this is way easier. It's way quicker. But you can't always do this. Actually, can you always do this? You can always do this actually for a quadratic. If they ask you for a minimum or a maximum, you can always do this. But the other method that we use where we find the midpoint of the x-intercept is sometimes gonna fail if it doesn't even have an x-intercept to begin with, like this. See here, this will never cross the x-axis. So that's gonna fail. So this is where this method comes into handy. B, determine the velocity of the ball when it is caught 1 meter above the ground. So what do you think they want? This one's a little bit trickier. Velocity just means here, I'll give you a hint. Velocity just means s prime of t, which we had before, right? Which we had before. There's negative 10t plus 30. What do you think this question is actually asking you? Do we just plug t as 1? Is that what it is? So you can't plug t as 1 because t is meters. Sorry, t is time, but the 1 meter that they've given you, that is your height, right?
Mm-hmm.
So plugging 1 as t is not going to work. This one, you need to do a couple of things. It's not too difficult. You first need to find at what time, right? At what time is the height 1 meters? To find this, you're going to use the height equation, this one. So we're going to let the height s of t be 1, and we're going to try and find t here. How do we solve this for t? It's a quadratic. And it's not too difficult. Any polynomial, bring everything to one side. I'm going to bring the 1 to the other side. I'm going to be left with a 0 here. What do I get on the other side? We're just subtracting 1 from both sides. So look at this, negative 5t squared plus 30t. And 1 minus 1 is a 0, so that goes away completely. What's the GCF? What can I pull out from the right side? You can pull out a 5. Yeah, you can pull out a negative 5t. That's right. What are you left with?
T plus 6.
That is, it's going to be t minus 6.
Mm-hmm.
T minus 6. So that means you set this equal to 0, you'd get t 0. You set this equal to 0, you'll get t is 6. So when the time is 0 and when the time is 6, the height is 1, yeah?
Uh-huh.
Does that make sense? And then you're going to plug this in there as t, and that'll give you the final answer. Cool?
Mm-hmm.
Don't worry too much about this. Just know the idea that the second derivative will give you the acceleration and the first derivative will give you the velocity. Notice both of these are position graphs they've given us. It says position. When is the velocity 0? Now velocity, okay, velocity is the tangent, it's the slope of the position vector. Velocity will be 0 when there's a turning point or when the slope is horizontal. Look at the first graph. Where's the tangent horizontal here? In other words, look for the turning point. See this one?
Mm-hmm.
What's the x value here?
3.
3, exactly. So when the time is 3, the velocity is 0 for the first one. What about this one? The b.
Which curve do you look at?
You look at all the turning points. If there's multiple, you look at both of them. So there's going to be multiple instances when the velocity is 0.
So
So
3 and 7.
yeah, 3 and 7, that's it. So t equals to 3, there's the velocity is 0, t equals 7, the velocity is 0, okay? These are called tangent lines. A tangent line is a line that just kind of touches it at one point like this. This goes with the flow actually like that. Like over here, it's going to be like this. Over here, maybe it's going to be strictly horizontal like that. Same thing here, tangent line over there will look like this. That's a positive. If it's going up, it's gonna be positive. If it's going down, it's gonna be negative. It just slightly touches the curve. The second question here, when is the object moving in a positive direction? You just look for the tangent lines. You see the first one? This is a positive, this is positive, positive, up until it hits 0, and then starts going negative. So for this one, in a positive direction is when time is less than 3, it'll be positive. When time is greater than 3, it's gonna be negative. You see that? So
Mhm.
everything here is going down. What about for this one? Where is it positive? Then this is where it was horizontal.
When time is less than 3.
Yeah, but there's one more place where it's
When
positive.
it's greater than 7.
Yeah, exactly. So time is less than 3, or when it's greater than 7, you have positive. And then between them, between 3 and 7, you have negative. That's when it's the slope thingy is negative. Cool.
Mhm.
That's all there is for that one. Okay, here, let's try doing this. Again, it's a quadratic. It's not even a trinomial. It's pretty simple. Calculate the ball's initial velocity. They've given you the position function, the distance function. They're asking you for the velocity. What do you do? How do you go from distance to velocity?
You find the derivative.
Yeah. And this one, initial means you find the derivative first, and then you plug time is 0, because initial just means time is 0. What's going to be the derivative here?
Negative 10t plus 25.
Yeah, negative 10t plus 25. Plug t as 0, you'll get the initial velocity of 25. That's always going to be y over x. On the y, we have meters. On the x, we have time in seconds. So there you go. Part A, it's going to be 25 meters per second. Part B, calculate the maximum height. Now, if you graph h of t, you get something like this, okay? This is the
Mhm.
maximum height. This is h of t, the position function. What happens at its maximum height? Something is 0.
The slope.
The slope is 0, right? So you see this right here? This is the slope function. We set this equal to 0 and solve for t. What do we get if you solve for t? Or how do you solve for t? It's just a linear function, negative 10t plus 25. You can either add 10t on both sides, or you can subtract 25 on both sides. So negative 25, it's negative 10t, and then divide both sides by negative 10. T will be 2.5 seconds. Yeah.
Mhm.
So the maximum height occurs when the time is 2.5 seconds. And you just gotta plug that back into the equation, into this equation, into the height equation. So negative 5 times 2.5 squared plus 25 times 2.5. That gives me 31.25 meters. That's the maximum height. Cool.
Uh-huh.
What we found here is we found this time here. This was 2.5, and then we're trying to see what the y value is when the time is 2.5. When does the ball strike the ground, and what is its velocity at this time? What do we do here? When the ball hits the ground, yeah, what is 0? Something's gonna be 0. You base,
Meters.
yeah, meters, the distance is gonna be 0. So basically we're trying to find the the x-intercept of h of t. The speed is not gonna be 0. It's kind of weird when you think about it. Oh, well, if you just draw a tangent line here, you notice that it's not horizontal. The speed, it's gonna come to a stop eventually, right? It's because the ground or whatever is gonna eat up all the energy, but at the moment of impact, the speed is not zero. It's gonna be very high. So to do part C, you just find the x-intercept of the position function, of the meters function. So like this. To find the x-intercept, set y equal to 0. Like that. Yeah?
Mm-hmm.
How do you solve this for t? If you can pull something out, always do that, as long as the other side is 0.
You pull out negative 5t.
Okay, now be careful. What are you left with the bracket? Be careful of the signs. I'll give you the first one. The first one's gonna be t. What else?
-5.
Yeah, -5. So this means this is 0, negative 5t is 0, that means t is 0. Or this is 0, that means t is 5. Okay? This one, we already knew this. This one, because the y-intercept here is 0. So we know it started at the origin. We're not interested in this. We're interested in this. Okay? So at 5
Mm-hmm.
seconds, it's going to come back into the ground. What is its velocity at this time? What do we do this for this one? We need to find the velocity when the time is 5. Do we have the velocity function?
Yes.
Yeah, we do, right? H prime of t is the velocity. So all you got to do is plug TS5 into that and you'll get your answer. Are we expecting a positive number or a negative number? Look at the slope here. Is this positive slope or negative slope?
Negative.
Yeah, so we're expecting a negative number. So negative 10 times 5 plus 25, negative 50 plus 25 is going to be negative 25 meters per second. And that's going to be the answer. Cool?
Mm-hmm.
Well, negative there just means it's coming down. Negative means either it's going up if it's positive, or if it's negative, it's coming down. Okay, here's a trick question. We know the speed up here, the speed or the velocity was 0. How come its speed down here is so much higher? It's like something is pulling it, whatever this is, a ball. Something is pulling that ball back into the ground. It's like a force, something like, what is that?
Gravity.
Yeah, exactly, it's gravity. And gravity has a value. Gravity is a measure, it's acceleration, okay? Gravity is the same thing as acceleration. The value of gravity is 9.81 meters per second squared into the ground. It's negative. It's going to pull everything into the ground at that acceleration. Okay?
Mm-hmm.
We don't really care about that. Here's a question. You see this right here? Let's say this is a quadratic graph. This is the vertex, right? The maximum. What is 0 here?
The slope.
The slope, but it doesn't have to be just like a quadratic, though. It can be something like this. What is 0 here? The slope, right? What is 0 here? The slope. What is 0 here? The slope. Same thing here. These are called minimums. What is 0 here? The slope. What is 0 here? The slope. Yeah?
Mm-hmm.
Wherever there is a turning point, the slope is going to be 0. And it can either be a maximum, the turning point could be a max, or it could be a min. Yeah? The question
Mm-hmm.
is, how do you know which one is which? Let's look at a question. We know the slope is going to be 0. This one. Find the extreme. Extreme just means the maximum or the minimum, right? You can also say that in the context of weather, or climate, I guess. Extreme climate means in the summer it gets really hot, and in the winter it gets really cold, kind of like that. So we know for a fact we're looking for the slope, or in fact we're looking for when the slope is 0. They've given us a function, we don't care what it is. We're gonna straight up find the derivative because this is gonna give us the slope. What's gonna be the derivative of this cubic polynomial they've given us?
Negative 6x plus 18.
Negative 6x squared plus 18x. Okay.
Mhm.
And we know at the extreme values, the y value is going to be 0, or f prime of x is going to be 0, like that. Again, this we've done it a few times. We can pull out a negative 6x. What are we left with? First term's going to be an x. What's the second term?
Negative 3.
Yeah, negative 3. So this means when x is 0, you have a turning point, and when x is 3, you have a turning point, yeah?
Mhm.
But now which one is the maximum, which one is the minimum? How do you know that? Well, you're simply going to plug it back into the equation over here. F of 0, just ignore all the x terms, that's going to be a 4, right?
Mhm.
And then you can also find f of 3. This one you're going to need a calculator. Or you really don't, but you should, I guess. It's quicker. 3 squared plus 4. That wasn't too bad. Actually, it's 31. So tell me, which one is the maximum and which one is the minimum? Is 0 the minimum or is it the maximum? Look at the y value. This is the x values, right? These are the y values. We know this is a cubic polynomial. The y-intercept is given in the question 4. We know it starts in quadrant yeta, some quadrant. 2, always. If it's a negative cubic polynomial, it's going to start in Q2, it's going to end in Q4, yeah?
Mhm.
How many turning points can it have? If it's a cubic, it can only have a maximum of 2 turning points like this. Okay?
Uh-huh.
So we're not really interested in anything apart from negative 3 to 5. So you can even kind of ignore that. So now look at this. When the x value is 0, you have a y value of 4. Okay, maybe this is going to be a better. When the x value is 0, y value is 4. When the x value is 3, what's the y value?
31.
31, exactly. So that means this guy is your minimum, okay?
Mhm.
And then that guy up there is your maximum. And that's how you distinguish between which one is which. So that's actually what the graph should have looked like. And that's the whole point of this course. Last time around, we were just kind of like doing this, right? We don't know where this is, we don't know where this is. But now we know exactly where those are. So we can graph them precisely by hand. So the graph of this is going to look something like this. And we can also find the x-intercept here if we really wanted to. We've done that before. We need to use synthetic division after finding out what value of x gives us 0 here. But anyways, the point here is the minimum will have a lower y value. The maximum would have a higher y value. Okay?
Okay.
Min and max. Not doing that. mean, these ones are pretty simple, right? There's a max here, there's a min here. There's a max here, min looks like it's here. There's a max here. Is that the min?
Yes.
No, there's a number below that. If you look over here, this number, -1, is less than 0 for the y. So this is actually not the min. This is something that you call the local minimum. Give me 1 second. Okay, I'm back. So this one over here would be the minimum in a certain interval, but it's not the true minimum of the function, because if you look at this, there's another number here that's even lower than that, yeah?
Mm-hmm.
So the 3 there would be a minimum if they gave us an interval. But this question is asking you for the absolute maximum, right? Absolute means there's no interval. You look at the whole thing. Like over here, this is not your minimum because there's a number lower that, like there's a number lower here than this one. So this would be the minimum, this would be the maximum. Okay?
Uh-huh.
Absolute means, yeah, no interval. You're looking at the whole picture. Let's try doing a couple of these. Okay, and they want us to sketch it as well, but we know how to sketch it. These are all gonna be like quadratics and whatnot, or even cubic, so we can sketch them. And it's even easier if there's no y-intercept here. Like this one, it's a quadratic. Again, let's find the first derivative. That's all we're interested in, because that's when the slope is 0. What's gonna be the first derivative of this?
2x minus 4.
Yeah, 2x minus 4. Let's set this equal to 0. What is x? It's a linear equation.
It's 2.
Yeah, so when x is 2, we know for sure there's a turning point, right? Is this
Mm-hmm.
gonna open up or down?
Up.
Up, right? So like that. We know the y-intercept is 3, and we know that the x value where there's a turning point is 2. So now let's find the y value when the x value is 2. So it's gonna be 2 squared minus 4 times 2 plus 3. Well, this is 4 minus 8 plus 3. -4 plus 3 is a -1. So that graph is inaccurate. So it's actually going to cross the x-axis. So it should look something like this instead, right? Because we found out when the x value is 2, the y value is -1. That's why it should be below the x-axis. So tell me, you have 4 options. Classify this point. Is this an absolute minimum, absolute maximum, or a local minimum, local maximum? Like this one is a local minimum, whereas this one is the absolute minimum. Right? If you look at if there's no other point anywhere on the graph, then this should be absolute. If there is a point with a lower y value, then it would be a local minimum. Which one is this?
Absolute minimum.
Yeah, it's an absolute minimum. Because there's no way, we know for a fact the quadratic, the graph will never go underneath the vertex if it's opening up. So that there you go. X equals to 2 is the absolute minimum of this function. Okay? X
Okay.
equals 2, yay. Let's do one that goes a little bit higher. This one is a cubic polynomial. It's positive. It's gonna start in quadrant 3. It's gonna end in quadrant 1. All right, let's find the first derivative. F prime of x. What would that be? We're just straight up trying to find the first derivative.
3x minus 6x.
No, 6x is right, but not 3x. 3x what? 2, right? You need to just subtract
mhm.
1 from the exponent. 1. So then we know for a fact the y value for the slope function is going to be 0 because the slope at that point is horizontal. So we're going to let this be 3x squared minus 6x. And then from here, this, you know how to do this. It's going to be x minus 3. So that means 3x is 0, x is 0. And we know x minus 3 is 0, x is 3. Yeah? Make sense so far?
Yeah.
And then we're also going to find the y values. And we're going to classify whether it's a minimum or it's a maximum. So f of 0 is just going to be a 0 because there's no, if you can just plug x as 0 to see that. F of 3 is going to be 27 minus 3 times 3 squared. What is that? That's a 0 as well, right?
Uh-huh.
So what does that mean? We know we're starting in quadrant this one, and we know we end up in this quadrant, yeah? We know we're going through the origin. Wait a second, I didn't factor this right. There should have been a 3x squared here, like that. And yeah, no, this wasn't done well, was it? Let me just double check. 3x, no, that's good, that's good, that's good. I'm trying to factor this one. Let's try factoring this one. For this one, we can pull out an x squared, yeah? Then what are we left with? X minus 3, right? Here's a distinction that I don't want you getting confused. This thing here is the slope is 0, okay? The slope is 0. That means there's a turning point somewhere, right? This doesn't give you the x-intercepts. X-intercepts are given to you by the main function itself. So if you look at these two, there is an x-intercept. If you set this equal to 0, this equal to 0, there's going to be an x-intercept at 3. And then x squared is 0. That means there's going to be an x-intercept at 0. Okay? It's a positive cubic polynomial. Which quadrant does it start in? Which quadrant does it end in?
It starts in the third and ends in the first.
Yeah, exactly. Now, if you remember from a couple of months ago, I think, I don't even know. Actually, you don't even need to recall that. Just know there's going to be a turning point at 0, 0, right? Because we found when the x value is 0, there's going to be a turning point we like that. And then where else is there a turning point? Where else is the slope 0?
At 3.
At 3, right? So that means there's going to be another turning point there. Something like that. Is that an absolute max or a local max?
A local?
Yeah, what about this one? Abs or local? Remember, it's going to go up and down infinitely.
It's also local.
Yeah, what about this one here?
It's a local minimum.
Yeah, exactly. So for an odd degree polynomial like x3, x5, there's never going to be an absolute because it's going to go up and down infinitely, right? So there's always a number that's minimum than one of the turning points. Same thing on this quadrant. There's always going to be a number that's bigger than whatever the turning point is. You'll only get an absolute if it's like an even degree polynomial like x4 or something like that. Here, let's try doing this one. Same idea, but now it's not a polynomial anymore. Doesn't change anything. Let's find the first derivative. You got to use what? Quotient rule, right? This is f, this is g, on the bottom, the entire thing, and quotient rule says it's f prime g minus f g prime over g squared. What's f prime?
4.
Yeah, times the denominator as it is, minus the numerator as it is. What's the derivative of the denominator?
2x.
Yes, all over the denominator squared, so it's going to be x squared plus 1 squared like that. And we know the slope, the y value, is going to be 0 here. Yeah?
Mm-hmm.
So we can clean this up a bit. It's going to be 4x squared plus 4 minus 8x squared. So on the bottom, you'll just get this. So this means you get minus 4x squared plus 4 over x squared plus 1 squared equals 0. Something like this you'll get after you clean it up a bit. Any ideas on how to find x? What can we do? Look at this, this is actually not that bad. If you multiply both sides by the denominator, yeah, you see this?
Mm-hmm.
If you multiply both sides by that, it's gonna go away from this side. It's also gonna go away from the other side because 0 times anything is a 0. So you're just left with this quadratic. Yeah?
Uh-huh.
If you pull out minus 4, what are you left with? Well, actually, you don't have to pull anything out. Let's just subtract 4 from both sides. So you'll get negative 4x squared equal negative 4. X squared will be 1. If x squared is 1, what's x? It's going to be plus minus 1. Okay, square root of both sides. Square root of 1 is plus minus. Square root of anything is plus minus, right?
Mm-hmm.
So minus 1 is not even in our interval, so we're not interested in that. We're interested in plus 1 though. So let's plug 1 back into this to see what we get. If you plug f of 1, you're going to get 4 over 2. That's a 2, yeah? But we don't know if that's a minimum or a maximum right now because you need something to compare it with, right?
Uh-huh.
Right now you don't know what that is. So what's the trick that we can use? Well, let's just plug any other value in from the interval in there. So let's plug f of 2. Let's see what that gives us. So that's going to give us 4 times 2 over 2 squared plus 1. It's 8 over 5. It's 1.6, right?
Mm-hmm.
So at 2, you're at 1.6. At 1, you're at 2. So is this a maximum or a minimum? It must be a max, right? It must be a local max because they've given you an interval. It must be a local maximum.
Uh-huh.
Because if it was a local minimum, this number that we got, you can put any points from 2 to 4. You can put 2.5, 3.5. Any of these numbers would have given you a lower y value than what you have right now. So that point, 1, when x value is 1, when the y value is 2, must be the local maximum in this interval for this rational function. Okay?
Uh-huh.
All right, what are you doing in school this week if you know?
I don't really know yet.
Okay, cool. I guess we'll find out when we meet again next week.